All right, so number one is says solve by graphing, but you can use your calculator, right? So we just got to go through the steps to remind you how to do those. All right, so here's the system. We have a line, and we have a parabola. All right, so the first thing we have to do to use our calculator is to set them equal to, get y by itself, right? Get the y equals. So we can hit that button. You guys shut that for now. That's basketball stuff, right? Yeah. That's what I thought. Pay attention, okay? When we're done, you can do that. All right, so when I get y by itself, I'm going to take this 3x over by subtracting it, right? Let's pay attention to this one right now, all right? Then we can work on that other one. All right, we all good with that? All right, some of you I saw were moving the y over, but that makes it a negative y. And then when you bring the 3 over, it's positive 3, but then you got to divide by negative 1. So you're doing more work for yourself. So just leave the y on the left. Okay? On this one, I'm just going to leave the y on the left and take the 5x squared over. How do I move that one over? Yeah, subtract it. So this parabola, does it open up or down? Down. And if there's no symbol in front of the 2x, it means it's positive, right? So we're going to put a plus 2x. So there's our two equations with y by themselves. So you got to do that correctly, or you're not going to get the right point of intersection, right? You got to have your signs correct. All right, then we go to our calculator and hit our y equals button to graph this on our calculator. All right, so hit my y equals, and I'll put the line in first. Remember, the negative sign's down here at the bottom, and then minus 3 for the second part, the subtraction symbol. And then again, the negative sign, and then 5x squared plus 2x minus 3. All right, hit enter, so they're in there. All right, and if you're having trouble, you know, sometimes you guys, I know some of you are doing some chemistry stuff, and you're turning your stat plots on, and you're doing some graphs with chemistry. To turn your plots off, just hit second y equals. See, all mine are off. But if one of yours is on, if you hit 4, that says plots off for 4, and then enter, that turns them all off if you're getting issues with your calculator. All right? And then you can hit zoom 6 to get that basic window that's negative 10 to 10 for the x's, negative 10 to 10 for the y's. Okay? So there's our graph. Okay? For this problem. But we're not done. We're looking for the points of intersection, right? It's a system of equations, right? So I got to find those points of intersection. And it looks to me like there's 2 points. It's kind of hard to tell, but I'm pretty sure that, well, let me get that a little bigger, but it looks to me like there's a point here somewhere and over here somewhere. Okay, that's what it looks like. So we have to find those 2 points of intersection, okay? And again, the calculator does this for us, all right? we hit our second trace button, which is our calculate menu. And number 5 there says intersect. Okay, we're looking for intersections. All right, so we're gonna hit 5. And when you always do this calculate menu and do stuff on it, it always starts at the y-intercept, okay? And that looks close to this point of intersection here. So I'm just going to hit enter 3 times and see what it gives me. So there's the first curve, I hit enter, second curve, I hit enter, and then the guess. So the calculator's asking, you to kind of give it a better idea of where it wants you to look, or where it's supposed to look, okay? And it actually is the y-intercept, is -3 for both of them. We could kind of tell that if we look at the 2 equations. Remember, the c value is your y-intercept, right? And this is y equals mx plus b, and the b value is on a slope-intercept form, gives you the y-intercept, right? So you got a -3 right there just by looking at it, okay? So one of our solutions is 0, -3, okay? And then I'm going to do the same procedure, the same steps. Second, trace 5. And I'm going to hit my right to move your cursor. You hit the right and left arrow keys, not the up and down. So I'm going to hit the right arrow key to kind of move it down here towards that other point. Okay, so that seems about, I'm pretty close to that point of intersection. And then I just hit enter 3 times. So that's the line, first curve, and that's the parabola, second curve, and then the guess, see where they meet. And that's 1, -6. So you're going to have to get y by itself if it isn't already done for you tomorrow on the quiz. Put it in your y equals button, graph it, and then do those points of intersection. If you want to sketch the graph, you can. You don't really have to because I told you it's all calculated. Cindy? Any questions? All right. So that should be, we should all get that one right, shouldn't we? As long as we get y by itself correctly, we should be able to do that. So we're good with that one? Okay. Number 2 was solved by substitution problem. Another system. All right. This system had a circle and a line. Okay. So that's our system here. So the y is already by itself. So we take whatever y is and put it in to the circle equation for y. All right, put it in that spot. And then we just do the math. All right, so we got that x squared. And then instead of plus y squared, we're substituting what y equals, which is x plus 1, in for y. Okay, so that's what it looks like, the first step when we do that substitution. Okay, and now I square the binomial, which means x plus 1 times x plus 1. So if you want to write it twice in FOIL, you can. I do the shortcut where I take the first term and square it, x times x. I multiply the 2 terms together, x times 1 is 1x. But the part you got to remember is to double that or multiply that by 2. So 1x times 2 is 2x. And then square the 1. 1 times 1 is 1. So it looks like that. Okay, a lot of you just put x squared plus 1. You forget that there's a third term, that middle term. Okay, so don't forget about that. Now, we're going to simplify this and set it equal to 0 so we can solve for x. All right, so what we have now is a quadratic equation that we have to solve. Okay, so the 2x squareds give me 2x squared. I just have the 2x. And when I subtract the 13, I get negative 12 to set it equal to 0. And then you can use the quadratic formula, or you can try to factor it. Okay? Either way will give you the same answer. All right? If I factor this, the GCF is 2. I'm going to pull that out, and I get x squared plus x minus 6. And I can factor negative 6 and add those two factors. Positive 3 times negative 2 gives me the negative 6. But when I add 3 plus a negative 2, I get that positive 1 in the middle. Okay, so I just factored it. Okay, but again, using the quadratic formula will give you the same answers. All right, so finishing that part up, remember we said each factor equals 0. Even though 2 is a factor, I can't say 2 equals 0. If 2x was a factor, then I would write 2x equals 0 and get a third answer. Okay? So I'm going to subtract 3 from both sides here. So one of my answers is negative 3. And I'm going to add 2 to both sides here. But that's only half done, right? All right, this is a circle with a line that goes through it. It's got 2 points of intersection. So I have to find the 2 y values that go with that. So I'm going to rewrite the y equals x plus 1 so we can see here. All right. So I'm going to put negative 3 in for x. And I'll put positive 2 in for x. So, oops, 2 plus 1 is 3. So one of my solutions is 2, 3. And the other solution is negative 3, negative 2. So there's 2 answers to this one, just like the first one. 2 points of intersection. The first one we did by graphing using our calculator. The second we did by substitution. Okay. Questions? No one.
Where did the 2x come from?
The 2x?
Yeah.
If you FOIL x plus 1 times x plus 1, you're going to get an outside 1x and an inside 1x. So that's going to give you a 2x. So the way I do it is I multiply those two together, which is 1x, and then I multiply that answer by 2. That'll always give you the correct middle term. Any other questions? All right, so number 2 you're going to do by substitution. Okay, number 1 is going to be worth 5 points. 2, 3, and 4 are going to be worth 10 points. So it's going to be a 35-point quiz tomorrow. All right, number 3, you have to graph the 2 inequalities on the same xy axis and then shade them. All right, so the first one is y is greater than x squared minus 6. And the second one is y is less than or equal to negative 2x squared minus 4x minus 1. Okay? So all we're doing is graphing those, and you guys have been using your calculators, I think, to graph them, right? It's already got y by itself, so that's fine with me. Go back to your y equals, clear that out, and put x squared minus 6. And in this one, it's a negative 2x squared, so I'm just going to change that 5 to a 2. minus 4x and minus 1. And now I'm going to hit graph then. You got the one that opens up, the blue one, and the one that opens down, the red one. Okay? So I'll just pull it over. You guys will sketch that. And again, it doesn't have to be perfect. All right? But we have to make sure that it's either dashed or solid, and then we got to shade what needs shaded when it's an inequality like this. Okay? Is the blue one dashed or solid? Dashed. Because it doesn't have the equal to. All right? So this one here, the one that opens up, is dashed. Okay? Now, let's just do a test point. Is 0, 0 a good test point for this one? Is 0, 0 on the parabola? No. So any point that's not on the parabola is a good test point. So I put 0 in for y and 0 in for x. I get 0 is greater than negative 6. Is that true or false? That's true. So 0, 0 is here inside it. Or what we've been saying, greater than, it opens up, is inside it. Less than, when it opens up, is outside of it, basically. All right, so, all of this is shaded for that one that opens up, the blue one. For the red one, is it solid or dashed? Solid. It's got the equal to, right? So this is solid. Now, I can use 0, 0 as a test point, right? Let's use 0, 0 again. Okay? Put 0 in for y and 0 in for x. And it's still 0 on the left. And over here, 0 squared times negative 2 is 0. Negative 4 times 0 is 0. 0 minus 1 is negative 1. Is that true or false? Is 0 less than or equal to negative 1? False, right? Now, look where 0, 0 is. It's on the outside of it, right? So since it's false, I got to go to the inside to shade. When it's a false statement, you go to the opposite area. You with me on that? So it would be inside here that I'm shading on this one too. All right? Now we want to see where they overlap, right? Where the red and the blue overlap is the answer. Okay? So I'll use a highlighter for that. So this area here should be what you had shaded, the overlapping part. That's the answer. Every point in that highlighted area, if I plug into the blue one or the red one, will be a true statement. Any point in there. There's an infinite number of points in there. So that's why we shade it, so we can draw a picture of all the answers. We couldn't list all the answers. We could do that forever and never stop. Questions so far? Making sense? Okay. Number 4. is a quadratic inequality with one variable, just x. There's no y. Okay? Instead of the greater than y, it's greater than 2. Okay? So this one is the number line graph when we solve it. Okay? Before we can solve it with our number line, we've got to get it 0 on the right, greater than or less than, greater than equal to, less than equal to 0. It's got to be a 0. So I got to subtract 2 to start. So I've got x squared minus 6x plus 8 is greater than 0. You can factor this. But I'll just do the quadratic formula on this one just to show you the other way you can do it. All right? But if you want to factor it, it's okay. It gives you the same answer. All right? So x equals negative b. B is negative 6 plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 8, all over 2 times a. All right, so that's just using our quadratic formula. So the minus and negative 6 makes it positive 6. 2 times 1 is 2. Let's see what we get under there. Negative 6 squared is 36. Negative 4 times 1 is negative 4. Times 8 is a negative 32. That's 4. That's nice. What's the square root of 4? 2. So I can make this 6 plus or minus 2 divided by 2. All right? And then there's two answers I got to find there. Okay? These two answers we call the critical values. There's the numbers we're going to put on our number line. All right? And then we'll graph our number line. So we got 6 plus 2, which is 8, divided by 2, that's 4. We got 6 minus 2, which is 4, divided by 2, which is 2. So there's my two critical values, positive 4 and positive 2.
Can you simplify that further so you have to divide?
Yeah, I could have made it 3 plus or minus 1, yeah. Right. Yeah, I could have. So I go, make my number line, and I put 2 and 4 on here. Now, look at the original problem. Will I have open circles or closed? Open. No equal to, they're open. If that had the equal to, we make them closed circles or solid dots. Okay? So, what number should I pick to the left of 2? 0, right, that's the easiest. But 1 would be okay too. Between 2 and 4, what should I pick? 3. And to the right of 4? 5, right? 5, 6, whatever you want. But I usually try to go closest to. I always try to use 0 if I can, which usually you can, unless it's one of our critical values. Right, Wolf? All right. So now I'm going to put 0 in the original problem, 3 in the original problem, and 5. Okay? And see what works. Whatever works, I draw a line or arrow in that section. Okay? So, I'm going to put 0 in first. Well, that's 0, so is that 10? Is 10 greater than 2? Yeah. So I'm going to draw an arrow towards the 0. All right? Then I'm going to put 3 in there. So 3 squared is 9, minus 18 plus 10. 9 plus 10 is 19, minus 18 is 1. Is 1 greater than 2? No. So I wouldn't connect the two circles. All right? And I'll put 5 in. Well, 5 squared is 25, plus 10 is 35, minus 30. Negative 6 times 5 is a negative 30. That's 5. Is that greater than 2? Yeah. So, it's going to be like that, our graph. So, again, to get full credit on that, you've got to find the two critical values so you can graph the number line and show all the solutions. Again, that has an infinite number of solutions. All the numbers less than 2 or greater than 4, if I plug into the original problem, will be greater than 2. Any numbers between 2 and 4 won't be greater than 2. We feel more confident now about this quiz? I think it's pretty easy, isn't it? I hope you guys do too. All right, good job today. We'll do that tomorrow. Start exam review Thursday.